right now, guys. Okay, so let's wrap up chapter 6, example 4. What's the sample size needed to estimate the population mean? Average means mean. Within $0.50. Within, guys, should be a clue for you that what comes after within is the margin of error E. When the confidence is 98% and the population variance is 25, well, he gives you population variance. Usually they give population standard deviation. Well, if the variance is 25, the population standard deviation is the square root of it. So it's going to be 5. The formula, guys, is this: ZC sigma over E. There are two formulas for the sample size. This we use when we estimate the average, and the other one we use when we estimate the proportion. And look, it's obvious, guys. Here it says proportion. Here it says mean. Population mean or population average. Okay. Sigma is given to me, which is 5. E is given to me, which is 0.5. The only thing I need to find ZC. And I've been showing you how to find ZC. Let me just do this one more time. Inverse norm. Okay, you have 98%. So this is what you do, guys. If you want a formula, it's 100% minus 98%. And then don't forget to divide by 2 and then put 0 and put 1. So it will be inverse norm. 2% divided by 2, 1%, 0.0101. And if you do the math, it's going to be negative 2.33. You use your calculator. So just put 2.33. We use the positive part of it. So it will be 2.33 squared times 5 squared. If you wonder about the 25, it is standard deviation raised to the second power, 5 squared, and 0.50. The answer is 542.89, and you always have to round up, so it goes to 543. The next question, example that I've shown you the solution. What's the sample size needed to estimate the population proportion to within 3%? So that's E. When the confidence level is 95%, does anyone remember what ZC for 95 is? There are 3 values. Would anyone tell me without looking? It starts with 1 point. What's the confidence? What's the critical value for the 95% confidence level, guys?
1.96.
Yep. 1.96. All right. So here's the formula. N is P hat. P hat is the sample proportion. He didn't give it to us, so that means we're going to use 50-50. So that's why we have a 50, and here it's a 50, 0.5. Z is 1.96. This is 1.96 squared, guys. And E is 0.03 squared. And if you do the math, it's going to turn out to be 1067.1. You have to round up always. So it will be 1068. Let me just... number 1, we didn't do yesterday. Let's do this one. Lab tested 12 chicken eggs. So N is 12. Usually a small sample size, guys, means it's a T, not a Z. But let's see here. And found that the mean amount of cholesterol from the sample was 246 milligrams. With S, look how clear here. He tells you S equals 11.7 milligrams. Construct a 95% confidence interval. So what is it going to be, guys? A Z interval, a T interval, or a proportion Z interval? I know the answer myself. So can you share it with me?
Would it be the T interval?
T, yes. And the reason why, once he give you S, guys, you're using a T distribution. When you don't have knowledge of sigma, The population standard deviation, it's a t-distribution. That means a t-interval. I cannot tell you how important to distinguish between the two, because if students end up not doing well on this part of the test, chapter 6, because they get confused between Z and T, you cannot do that. Look, he make it clear. He put S here. Only when he gives you sigma, you use Z. If there is no sigma, it's only S. The difference between sigma and S is the following. S is the sample standard deviation and sigma is the population standard deviation. So let's do this one. Turn the calculator on and go to stat, tests, number 8, T interval. I don't have data, stats, and I got. And then I'm going to show you how to use StatCrunch for this, guys. You like that. So 11 X bar is 246. X bar is 246. 11.7 is S. N is 12. And then the confidence level is 95, guys. Calculate. And that's the interval. I'll write it down. 238.57 and 253.43. Now to write your conclusion in words, guys, you say, with 95% confidence, we can say that the true mean cholesterol content of all such eggs is between 238.57 milligrams and 253.43 milligrams. Okay, that's number 1. Let's go to the next one. No, before we go to the next one, I'm going to show you how you could have done this in StatCrunch if you wish. So if you have a data set, guys, while doing your work online and you are asked to do the interval, I think it will make a lot of sense, you know, to do it in StatCrunch rather than typing in the data into your calculator. And let me show you how you could do this. You can go to StatCrunch in 2 ways. You can log in using statcrunch.com using the same credential that you use to sign into my stat lab. Or you guys, if you're doing a problem online in my MATLAB, just click, you know, on the tab where it says where the data set is. Usually it's on the right-hand corner, and then it's going to open StatCrunch automatically for you. So if you wanted to do this exercise that I just did, look what we could have done in StatCrunch. You go to Stat, right here, no graphs anymore, Stat. Okay. Can you guys, given what we just did, can you tell me which tab I'm gonna click on now? Any ideas? It's between this and that. Z or T, what did we decide? We decided it's T, right? So we do T. Let me see. Yes, T stat, you are correct. And then one sample. In chapter 6, it's only one sample. I don't have data here. He didn't give me a raw data set, so it's a summary. And watch. The sample mean, guys, it's 11. It was 246. I'll put 246. The sample standard deviation was 11.7. The sample size was 12. And now if you go, this is for chapter 7 here. I'm not going to worry about it. So it's just confidence level. Select it. You have to select it. And it was 95%. And watch, compute. Here you go. The lower limit and the upper limit. The lower limit is 238.566. That's what I got, 57. And the upper limit is 253.43. That's your confidence interval. Even if you want to copy it and paste it, you just can select it, Control C, and then again, Control V and paste it into a Word document. So this is how we do this. Now, let's say you have a data set. How do you do an interval? Let me just put some data there. Okay. Let's say I have some data and I need to create an interval. When you have a small data set, guys, it's usually a T interval. So watch. Here's what you do. Stat, T stat, one sample. Oops. One sample with data this time. And look, select the column. It's in variable one. I selected and just select confidence level, 95%, whatever it is. If it is a 90%, let's say, I'll just put 0.90 and compute. There you go. You got the interval. 10.87 is the lower limit and the upper limit is 13.9. And look, degrees of freedom is 5. So that means the sample size was 6. 6 minus 1 is 5. And you can count 1, 2, 3, 4, 5, 6. So this is how easy it is to use stat crunch to find confidence intervals. Now, you could have used it also in chapter 4 and 5, guys. Look, if I go to stat calculator, I have two calculators. One is binomial and one is the normal calculator. Let me take you, for example, to the normal. Okay. You enter the mean, whatever the mean in the problem is. Let's say the mean is 100 and the standard deviation is 15. You just put it there and start answering the question. Let's say he asks you what's the probability that x is less than 70. Just put 70 here and watch, compute. There's the answer, 0.0227. Let's say you want to do a greater than 110. Compute. It will do that for you. You want to do in between, watch, it's right there. Let's say you want to do x between 33 and 110. There's not only it will give you the answer, guys, but it will give you a sketch of the area. So this is called the normal calculator. And let me show you the binomial calculator as well. You guys can see those calculators, right, that I'm projecting?
Yes.
Okay, look at the binomial. Binomial, you need n and p. So let's say n was 12 in a problem. And let's say p was 0.43. And now let's answer any question you can answer here. You have the between, you have the less than, and look, you have all the signs here. You have the greater. You don't need to do a 1 minus or anything when you use. So let's say, what's the probability that x exactly 5? There must be an equal sign here. Okay, let me see. Oh, here's the equal sign right here. Compute 0.227. This is the exactly, this is the binomial PDF. Now let's say he asks you what's the probability that x is more than 7. Look how easy it is. More right here, 7, just change this to 7 and make sure to press compute. There you go. So it did 8, 9, and 10, 11, and 12. It did all of those for us. It's 0.086. Let's say at most 5. At most 5 means less than or equal to 5. So watch. It's going to do 5, 4, 3, 2, 1, 0. And you'll see that marked in there. See? 5, 4, 3, 2, 1, 0. And it seems to me like 5 is the highest probability here. And compute, you just get the answer. More than, less than 5 means 4 or less. And you see, look, 4, 3, 2, 1, and 0. So this is the binomial calculator, the binomial CDF. And the other one was the normal CDF calculator. You could use them online as well. Okay, so this is it for stat crunch. It's very easy to use software. and you will be using it toward the last 2 weeks of classes. So it's good to just give you a glance of how to use the software. Now, if you're doing a proportion interval, guys, look, this is a proportion, one sample with summary. You enter the value of X, you enter the value of N, you enter the confidence level, and then you hit compute. Let's say number of successes is 300. Number of observation, N, is 560, and the confidence level is 95. Hit compute, and look, lower limit, upper limit. This is the interval for the proportion. So we did the T. Now let me tell you when you use the Z. The Z when sigma is known, section 6.1. One sample with summary, let's say, and look, sample mean, it didn't say sample standard deviation here. It says standard deviation. That's a population standard deviation, sample size, and then you select the confidence level. And you don't forget, just to select this radio button. Otherwise, you will be doing a hypothesis test. And then you hit compute. Okay. So I'm going to go back to my ladybug camera right here. Okay, next question. We did one question yesterday, the last one. We're gonna do 2 and 3. Okay. A college math professor has office hours from 9 a.m. to 10:30 a.m. daily. A sample of waiting times to see the professor in minutes is given here. Assuming that sigma is 7.84, find the 95% confidence interval for the population mean. Okay, guys. So we're going to put the data in L1, that's for sure. What is it going to be? I'm going to just put the 3 options, and you tell me which one to choose. Usually when he gives you a small data set, it is a T interval, but let's see if it is the case here, because he added some information here we didn't expect. So is it the first, second, or third, guys? Once you know which one you're going to be able to do, you're going to get the correct answer.
The second?
The second. And it is indeed the second, which is unusual to be the second. It should be the first always, but look what he added here, guys. He gives you sigma. Once he imposes sigma on you, the population standard deviation, guys, you have no choice but to use the Z interval. In most cases, guys, that will not be here. You just use a T interval, but since he did it, you have to use sigma. So I already have the data fed into the calculator, so I'm just going to show you how to create this interval. Let me show you where I put my data. Stat, edit. So my data, guys, is in L1, yes. So let me just clear this. Stat, tests. Okay, it's a Z interval. Let's say you made a mistake and you choose a T interval. I'm going to show you that you're going to find out that it's wrong. Watch. You put data. You choose L1. We're good so far. But there was no place to input sigma. And he gave you this information. There is no room in under T interval to put sigma. So you know that something is missing there. So just go back to stat, tests, and look with Z interval. It's gonna pop up just by itself here. Data, and look, it's asking you to input sigma, which is 7.84. So if there is no sigma, you go to Z interval, you're gonna be stuck because I don't have a sigma. How do I put it there? So then you know that you use the wrong interval. So it is easy to tell here. He gives you sigma, you have to input that one. L1, confidence level is 95. That's the most common confidence level, guys. And then calculate. Here's the interval. So the mean is between 18.86 And the standard deviation, the other side is 25.74. So you can say with 95% confidence, we can say that the true mean wait time for the students to see the professor before they can see their professor is about 18.86 minutes to 25.74 minutes. Must be an important professor, so everybody has to wait to see him. 3, a university administrator proposes to do an analysis of the proportion of graduates who have not found employment in their major field 1 year after graduation. In previous years, the percentage averaged 7%. He wants the margin of error to be within 4%. So anything after within is the margin of error, guys. So 0.04. At a 99% confidence level, what sample size will suffice? Use 2.575 as a critical value for a 99% confidence interval. So, okay, he already told us what the critical value is. Okay, guys, can you help me out here? I'm gonna do this easy part. 2.575 squared, 0.04 squared. What goes in here, guys? It's not a 50-50 because we have a prior knowledge of what the sample proportion was before. So can you guys tell me what's a p hat and what's a q hat here? Yes? P hat is?
Is it 7?
7%. So I change it to 0.07. And what's a q hat?
93.
93%. For students who are wondering where 93 comes from, 100% minus 7%. And let's me do the math. So 0.07 times 0.93 times 2.575 squared. And then divide by 0.04 squared. Okay, I got 269.78. You have to round it up. Remember, that answer will not be accepted. So answer is 270. That's the answer. We did this yesterday, guys, about a proportion interval. So that concludes the guided notebook that I provided you with. And now I'm gonna go to another sheet that I just emailed to you before the class started. Let's go over this, a quick review. What I need your help, guys, with is just tell me which test to use, which interval to use. That's the important part. So that's a good practice. So let's see, you have a Z interval when sigma is known, T interval when we don't have population standard deviation. This is what the mean is. And then we have a proportion interval for the proportion. Many people think that a national lobby's successful fight against gun control legislation is reflecting the will of a minority of Americans. So they believe that only minority of Americans, less than 50%, believe in gun control laws. A random sample of 4,000 citizens yielded 2,250 who are in favor of gun control legislation. Estimate, when he says estimate the true proportion, guys, is asking you to find a confidence interval. Of all Americans who are in favor of gun control legislation using a 99% confidence. N is 4,000 people, and X is 2,250. And guys, what is it that I'm gonna use? Z interval, T interval, one prop Z interval. I'll write them down again. What is it gonna be? That should be easy.
The proportion interval.
Proportion interval, definitely, because he's asking for the proportion. That's the only one. These are reserved for the mean. This is reserved for P. Keep that in mind, guys, for proportion P. So let's run the test. Very easy test now, since we know what to do. Okay, it's right here. Right here. So I got 4x is 2,250. I got 4,000. And we need 95%, is it? 99%. Okay. P is between 0.5423 and 0.5827. Here's a question for you. Based on the answer we got, guys, do you believe that gun control legislation is only reflecting the will of a minority of Americans? Is this a true statement? Yes or no?
No.
It is a no. Definitely it's a no, guys. You know why? Because the proportion that we got is more than 50%. It can be with 99% confidence, high level of confidence. We can say that the proportion of Americans who favor gun control legislation laws is between 54% and 58%. It's more than 50%, guys. So it does reflect the will of a majority of Americans, not minority. That's how strong. This is what CNN and polling, you know, just companies use. These are the kinds of studies that they do in order when they publish their results. It's all based on confidence intervals and hypothesis tests. If you guys recall during election, you watch the news, like for example CNN, the polls. You hear someone telling you that, oh, we expect this candidate, you know, to get 60% of the votes, but at the fine print, they say with the margin of error of plus or minus 5%. This is the confidence interval that we're talking about. So that 60% that they announce, it means 60 minus 5 or 60 plus 5. If you do a 60 minus 5 will be 55, and a 60 plus 5 will be 65. So the confidence interval is between 55% and 65%. They don't tell you the confidence level because most viewers or listeners don't understand what a confidence level is. So they don't mention that, but they do mention the margin of error because that's a must, because it's an interval. It's not only one value. But on the screen, when you see the TV screen, they put in bold the big number, 60% of the votes, but this is not, this is just only the sample proportion. But the fine print shows the margin of error, which is a plus or minus. Number 2, a researcher at a major clinic wishes to estimate the proportion of the adult population of the United States that has sleep deprivation. How large a sample is needed in order to be 99% confident that the sample proportion will not differ from the true proportion by more than 5%? That's E. I think we did this before, but I'm gonna do it one more time. Okay, he didn't give me P hat and Q hat. If he doesn't give you P hat and Q hat, guys, you have to use 0.5 for each. And I think you should know by now, by heart, 99% means 2.575. E is 0.05. The mistake that some students make, they put 99% here, 0.99. No, you need a critical value here, which is 2.575. So we did this one, always round up when you do the answer. So let's go to the next one. A researcher wishes to estimate the number of households with 2 computers. How large a sample is needed in order to be 99% confident that the sample proportion that sample proportion will not differ from the true proportion by more than 6%. So this is E. A previous study indicates that the proportion of households with 2 computers is 21%. He's given us a prior knowledge, guys, so that's a P hat. So your N is going to be P hat, Q hat, same formula as above for the proportion. Okay, your P hat is 0.21. So what is the Q hat here? The probability of failure, guys, 0.79, I agree. So I watch your screen, guys, as I do the work. Feel free to participate. 2.575 squared, and E is 0.06 squared. And you just do the math and get the answer. Round up. Number 4. Construct a 95% confidence interval of the population mean. Assume the population has normal distribution. A random sample of 16, N is 16, has a mean life of 645 hours with a standard deviation. He still refers to the sample. It's S. Guys, unless if he says population standard deviation, always put S. So it is S of 31 hours. Okay, so what is it gonna be, guys? It's Z or T?
T.
T. I agree. T interval and Y, guys, because of S. Okay, let's do it. Turn the calculator on. Go to stat. Go to tests. You will be use all of those tests that you see on the screen by the end of the semester. Chapter 7 and 8 will use all of them almost. Data, I don't have data, I have a summary. Stats. X bar. Okay, what is X bar here? Is 645. S is 31. N is 16. And he wants 95% confidence. Oops, sorry. I'll go back. All right. So 628.48 and 661.52. Make sure, guys, to double check later at home. Just do the, I say at home, you are at home. Just do the work later. So to make sure that you can do it. I know it does. The stuff might make sense to you right now as you watch me doing it, but the best practices are that you do it yourself. So, and if you want to write a conclusion here with 95% confidence, we can say that the true mean life of a battery, is it about battery? A lithium battery is between 628.48 hours and 661.52. Next page. Okay, number 5. A random sample of 10 parking meters in a resort community showed the following incomes for a day. Assuming that the incomes are normally distributed, find a 95% confidence interval for the true mean. Round to the nearest cent. Okay, you need to put your data in L1 or L2 or L3, whatever. What is it gonna be, guys? A Z or T? It's not a proportion because it's about the mean.
Is it Z because it's sample?
What is it?
Is it Z because it's a sample?
No, because he didn't give you the population standard deviation. It's always a sample. We always work with samples, whether it's a summary or he gives us a data set. Guys, since sigma is not giving, you cannot use Z. It must be a T interval. This is a T. We always have samples. In any situation, it's always a sample. Sometimes he gives us a summary of it. Sometimes he gives us the actual data. So this is a T interval. And to do this, your task, guys, for the next few days is to understand exactly when to use each. Otherwise, it will be a great disappointment because you'll be mixing up the stuff. So for this one, it's going to be T unless sigma is given. I will see if any of the problems where sigma is given. I'll do one more problem where sigma is given so you know how that we should be using Z in this case. So you go stat, tests. Even if I want to use Z here, watch, guys, look what the problem is. You need data. You see, it's prompting you to enter sigma. I don't have sigma. He didn't give me sigma, so that can't be a Z interval. Input, data. L1, where did I put my data? Let me check. Oh, I put it in L2, so I'm gonna go back to stat, tests. Watch, guys. Change it to L2. Here's how you change it to L2. Just press the second key and number 2. Okay, and what are we doing? 90%? 95%. 95 is the norm. It's the most popular confidence level. There you go. 3.39 cents and 6.01. With 95% confidence, you can say that the true income from a parking meter is 3.39 and 6.01. Number 6. A doctor at a local hospital is interested in estimating the birth weight. Weight, it means average, mean. How large a sample must she select if she desires to be 99% confident? So C is within 4 ounces of the true mean. That's E. 4. Assume that sigma, please change this number to sigma equals 5 based on earlier studies. All right. The formula, guys, is this for N. Okay. What is ZC for 99%? You should know it by heart now. We've done it already 5 or 6 times today. It's 2.575. He tells you that sigma is 5 and E is 4, and don't forget to square them. Let me see what the answer would be here. 2.575 times 5 divided by 4. And then square it. Okay, what's the answer, guys? I got 10.36. What answer would you put when you do, if this is a question on the test? Don't put 10.36, it will be wrong. 11, yes. Next. A survey of 1,010 college seniors working towards an undergraduate degree are conducted. Each student was asked, are you planning or not planning to pursue a graduate degree? Of the 1,010 surveyed, so that's N. N is the bigger number always. 658, that's X, said that they plan to pursue a graduate degree. Construct a 98% confidence interval. Okay. That should be easy. You don't have confusion here. There's only one interval that does proportion, guys. It's one prop Z interval. Okay, let's do it. Stat. There you go. X is 1010. Sorry, how many? 658. 1010. And the confidence level is 98 here. Don't forget to change that one because he says 98. You can put 0.98 if you want. Okay, P is between, not mean here. It's about the mean. It's not about the mean, it's about the proportion. So I got 0.6166 and 0.6864. You can say with 98% confidence, we can say that the true proportion of students who are planning to pursue a graduate degree is between 61% and 68%, or 61.6%. Any questions here, guys? Okay, number 8, you're gonna tell me which test do I use here. Just 1 second. I wanna see if I can do a poll here. Okay, so what do we use here for this one? Is it a Z interval, T interval, or a proportion Z interval? What do you guys think? Can I get an input from some students? Okay, I got T. Anybody else? What do you guys think? Don't be shy of participating, guys. It is important that you participate because you need to understand why we use what we use here. Yeah, I was gonna poll you and just ask everybody to participate, but it's just gonna take me time to create the questions. It is indeed a T interval, guys, because he did not give you sigma. You need really to understand that. So that is correct. Anytime, guys, you have a data set just like this, it is a T. So it's T interval. Put this data in L1 and run T interval. And if you guys, after your review, you're still confused about which one to use, please contact me via email or whatever. I will be more than happy to clarify this because that's very, very important. I think I put the data in L3, guys, right here, you can see. And then I'm just gonna run the T interval test. So we'll go to T interval number 8. I told you yesterday the T interval is the most important one. So data and then L3. And what are we doing here? Oh, I didn't say what confidence interval. So I'm gonna put the question here. Construct a 90% confidence interval for the mean. I don't know, this was cut off. So 90% confidence interval, guys. So just put 90 and hit calculate. And here you go. T is between, mean is between 94.87 and then 105.93. So you can say with 90% confidence, the mean pulse rate is between 94 or 95 beats per minute and 106 beats per minute if you want to round up to the nearest whole number. So this is it for the review, guys. Let me see how much time we have because we're gonna review for the test as well, but I'm just gonna show you. Okay, look in this section, guys, here. Let's look at number 35. From a random sample of 48 days in a recent year, US gasoline prices had a mean of 3.63. So that's X bar, N is 48. Assume that the population standard deviation is 0.21. Would you guys agree with me that here is giving you sigma instead of S? Because he says population standard deviation. If you agree, then it is a Z interval. Look at 38. In a random sample of 60 refrigerators, N is 60. The mean repair cost was $150. So that's X bar. Assume that the population standard deviation is 1550. That's sigma. You have to use Z interval. So once he give you make an assumption of the population standard deviation, you use Z interval. This is section 6.1. But if you go to 6.2, just like we did now, guys, it's totally different story. Like look at 26, for example. The question is to construct a 90% confidence interval. He just give you a plain data set, no population standard deviation. Then you use T interval. If you have a plain data set, it's always T interval. You want to see some other problems here? Just to you to this, I cannot say how important it is to distinguish between the two. Look at number, for example, guys, 18. In a random sample of 5 people, N is 5, the mean driving distance to work was 22.2, that's X bar. And the standard deviation was 5.8, that's S. He didn't say it's a population standard deviation, so you use T. And if you view the book, if you go to the e-text, he tells you how, he shows you a flow chart and how to distinguish between the two. Watch this flow chart, guys. Yeah. It's on page 314. He says, is sigma no? If your answer is yes, you must use a Z. If sigma no, if answer is no, you must use a T. As simple as that, guys. Okay, so this is it for chapter 6. What I'm gonna do now, I'm just gonna walk you through the practice test. So just bear with me for a minute until I get there, and then we'll do that and we'll wrap up for today. Binomial PDF, that is correct. Binomial PDF, you put N is 10 and P is 0.41 and X is 5. What about greater than or equal to 6, guys? How would you do this? You could do this. You could do binomial PDF on 6, on 7, on 8, on 9, and 10 and add them up. That's one way. If you're fast with the calculator, you can do it. Or he wants 6 and up. So then what he doesn't want is 5 and below. You can do a binomial CDF on 5 and then subtract the answer from 1. That's another way to do it. Probability of X less than 4. You know, guys, if X less than 4 means X is 3 or less, so it's at most 3. So here you run a binomial CDF on 3, and that should work right here. That's very much it for 4, guys. Let me take you to 5 now. That's 5. What's the area to the left of Z equals 0.88? 2 formulas you'll be using in chapter 5, normal CDF and inverse norm. This is gonna be probability, so it's normal CDF. You can see the lower bound is -1,000,000. Upper bound is 0.88. And since we're using Z here, guys, your mean is 0 and standard deviation is 1. And look, they gave them to us here anyway. Move to the next one. That should be easy in between. So your lower bound is -2.21, upper bound is 0, then 0.1. You don't need to use the tables, guys. As I told you, the tables will pop up, but he wants you to, you can do a normal CDF. Lower bound is 0, upper bound is 0.77, comma 0, comma 1. Here he wants you to change to Z-scores. You already have the value 2000 and then minus 1550 is the mean and divide by the standard deviation. Remember, a Z-score that is between -2 and 2 is usual, and a Z-score that is more than 2 or less than -2 is unusual. So he asks you to list which ones are usual or unusual. Area to the right of -0.05, so will be, guys, normal CDF, -0.05, then comma, million, comma 0, comma 1. You can fire it up like this, zoom in. You can see the curve. Now, no more 0, 1, it's X. So X less than 77, so he must give you a mean and a standard deviation. Look, he gave you the mean of 83 and standard deviation of 4. Can a student tell me normal CDF with what components do they go? What's the lower bound here? What would be the lower bound, guys? Let me see. Not many students are participating today. -1,000,000. And then what's the upper bound? 77. And then the mean and the standard deviation. Good enough, guys. Next. Same question, but it's a word problem. He gives you the mean and the standard deviation. What's the probability that X is less than 4? So you do a -1,000,000, then 4, then the mean, 5.5, then the standard deviation. What's the probability randomly selected study participant between 4 and 6? So that's easy, actually. Lower bound is 4 and upper bound is 6. And they just put the answer. What's the probability randomly selected study participants was more than 8? More than 8, guys, then 8 is the lower, million is the upper, or trillion, whatever you want to put there, and then mean and standard deviation. He asks you to check which events are unusual. Any answer that is less than 5%, guys, you list it as unusual. Let's move on. Same question, very much the same. Let's look at this one. I still have 5 minutes. You got the mean and the standard deviation. He asks you what percent of the set scores are less than 600. Guys, if he says what percent, what proportion, and what probability, it's exactly the same thing. So you just find the probability of X less than 600. So you get -1,000,000, lower bound, 600, upper bound, 512, a mean, and 106 standard deviation. You get that answer, a decimal. The only thing, guys, just be careful here. It's a percent. So change the decimal to percent right here. So let's say you get 0.35. So put 35%. B, if 1,000 set verbal scores are randomly selected, how many would you expect to be greater than 550? Does anyone know how to answer this question? We've done a few in chapter 5. If you go back to chapter 5 guided notebook. What would you do, guys, to answer this question? We need to know how many of the 1,000 would have a set score more than 550. Any ideas? I'm not gonna wait long because time is running out. So you find the probability of X greater than 550, and whatever this probability is, you multiply by 1,000. So probability of X greater than 550, guys, is normal CDF, 550, a million, 512, 106. You get a decimal answer multiplied by 1,000, you should get your answer. Here, it's section 5.3 where you have to find Z-score. and use inverse norm. So to find z, you need the inverse norm, guys. You need the area to the left, which is 0.1977, comma 0, comma 1. You get the area. Same thing. But here he gives you the area to the right. Remember, you need to provide the area to the left. So when you do an inverse norm of this z, you go inverse norm. You don't do a 0.0143. You do 1 minus 0.0143. You need this, the area to the left, and then comma 0, comma 1. Same question. He gives you the mean and the standard deviation. Asks what's the minimum pregnancy length that can be in the top 9% of pregnancies. How would you do the inverse norm here, guys? Can someone help me here? So it will be inverse norm. You need the area to the left. What is the top 9%? On the right. So what do you guys said here? Yes, 91%. I agree. So you do inverse norm, comma 0.91, comma 268, comma 8. You get the answer. Bottom 60%, guys, you just use 6% because that is at the bottom. It's on the left. Let's see what else. Okay, now we're doing section 5.4. Remember, when you work with the sample, here, for example, he gives you the height of full-grown trees of specific species are normally distributed with a mean of 75.5 and a standard deviation of 5.75. Random sample of size 13 are drawn. Use the central limit theorem to find the mean and the standard error. The mean, as you notice from the applets we did, is the same as the mean. So your answer should be 75.5. But the standard deviation of the sampling distribution is not the same as the standard deviation of the original distribution. It is 5.75, but you must divide by what, guys? Square root of n, and you need to provide the answer here, not just a fraction. And so you have to do square root of 13. I'm just write it down here so you know what I'm talking about, square root of 13. You do the math and you round to 2 decimal places. Last question. I'm just gonna do here. Okay, that's the last one. Sorry, we're beyond time, but just 1 minute, guys. And then the rest are chapter 6, which we just reviewed. The mean height of a woman in a country is 63.7 inches. A random sample of 65 women in this age group is selected. It's a very, very important question, guys. What's the probability that the mean height for the sample is greater than 64? So we need the probability that X bar, not X, greater than 64. I'm gonna write it down with the steps so you can see what I'm doing. Normal CDF. I think you guys agree this should have 64. Then you agree we should have 1,000,000. Then the mean, which is 63.7. And who can complete the last part? What would be the last number, guys? And I'll let you know, I'll go after that. We need the standard deviation. What would be the standard deviation here? Yes? Remember, 2.79 divided by square root of 65. Exactly, guys. Exactly, because you're finding the mean height, the probability of the mean height. So it's 2.65 divided by square root of 65. Yes. And then you get the answer. So anytime the question is about X bar, guys, you divide the standard deviation by the square root of the sample size. That's it. And you'll hear from me via email, and I will post the handouts. I'll post them online and send them to you.